Hello students, this is the chapter 12th of NCRT, area related to circles. We have discussed this chapter. Watch the videos are related to the chapter here www.edunetworking.com. Now this is a very useful website. You can go there and watch the videos related to this topic. Now in this video, again will be uploaded to the edunetworking.com. Now in this video, we'll discuss about the exercise 12.1 of the NCRT. The first problem of this chapter is the radii of two circles are 19 cm and 9 cm respectively. Find the radius of a circle which has circumference equal to the sum of the circumference of the two circles. Now the important thing is it has given the two radii of the two circles. Let's say you can say R1 19 cm. Second circle is also there. Let's say R2, that is 9 cm. Right? Now we have to find the third circle. You have to find the radius of the third circle. Let's say the radius of the third circle be R. Now the condition given here is circumference of the first two circles is equal to third circle. Means circumference of this circle, circumference of this circles, when we add, we get a circumference of the third circle. Right? Now circumference of the first circle here is 2 pi r. Right? Circumference means 2 pi r. Right? Now if we calculate 2 pi r here, that is 2 into pi into r, that is 19. Right? Here is the circumference is 2 into pi into 9. Right? That is 2 into pi into 19. Here is 38 into pi, that is 30. You can say 38 pi here. Here I say 2 into 9, 18 pi. Right? Now when I add these two quantities, let me add, because the third circumference is equal to the circumference of the first two circle here. Now 19 to 38 plus 18, it means the sum here is 56 pi. Right? Now let's come to reverse. This radius is this. Now circumference using this radius is 2 pi into r, which is equal to 56 pi. That means if I cancel this pi with the pi and 2 with 56, I'll get here 28. That means the radius of the new circle is 28 here. Now the important thing over here is the radius here is simply the sum of the radius of the first and the second circle. That is 19 plus 9 is 28. Here I am getting the answer as 28. Why it's so? Think about it. And think about it why it's so. When we add this radius here, it's getting the same radius here. The reason is 2 pi r is a linear quantity. This is 2 pi r. There is no square in it. Means the circumference is directly proportional to the radius. Circumference is directly proportional to the radius. It means when we add the two radius, it means circumference is directly added. Relationship here is linear. Right? Now, second problem here. The radius of two circles is 8 cm and 6 cm respectively. Find the radius of circle having area equal to the sum of the areas of the two circles. Now, the question is almost similar here. Here we use the circumference. Here the problem is asking about the area. The area is pi r square. Let me use a brighter pen more. Now the area is pi r square. Right? Now it's pi r square. Similarly, let me do here. The radius of two circles here is 8 cm and 6 cm. Here we are using the pi r square. Right? Now the area is pi r square. Let me do the problem here again. First circle, let be the radius r1. Let the second circle be r2. The area using the r1 is pi r1 square. Area using the radius 2 is pi r2 square. Right? Now pi r1 square, that means 8 square is 64. Pi into 8 square, that is 64 pi. Pi into r2 square, that is pi. R2 is 6 square, that is 36 pi. Now 64 pi plus 36 pi. Obviously the third circle has the areas equal to the sum of these two. Right? Now according to the problem, we have find the area of the first, we have find the area of the second. Now we have sum of this. This is got the 100 pi. Now this area is equal to the area of the third bigger circle, that is the of the radius r. Now I can equate it to pi r square. Now pi r square, let me this r square is 100 and r is 10. I got the result here is 10. Now again think 8 plus 6 is 14. Here is 10. Now here is the difference. Because why we are facing the difference here? Because here the area relation is square of the R. It's not the linear relationship, it's a quadratic relationship. We call it as a quadratic relationship here. Initially it was linear, so it was dependent. Or you can say 8 square plus 6 square equal to 10 square. Here is the Pythagoras theorem. We have used the Pythagoras theorem. Its use of here is 8 square plus 6 square equal to 10 square. You can think in that way. Think more about it and discuss with your friends, and if possible comment and discuss with me. Right? Let's come to the third problem. Third problem says in figure 12.3, it's a figure in the NCERT book, right? This figure in NCERT book 12.3 depicts an archy target marked with its 5 scoring region from the center outwards as gold, red, blue, black and white. Diameter of the region representing gold is 21 cm and each other hand is 10.1 cm. Find the area of each 5 scoring regions. Now let's understand the problem here. It's archery over here, right? The outermost region is white, then we have a black region, then we have blue region, then we have red region, then we have gold region, right? White, black, blue, then red, then center is a golden region. Given thing is diameter of the golden region is 21 centimeter. Given is diameter of this golden region is 21 centimeter. This is golden, right? 21 centimeter, and each other band is 10.5 centimeter wide. Now this distance is 10.5 centimeter, then this distance is 10.5, then this distance is 10.5. Each of this distance are 10.5. Each distance here is 10.5 centimeter. Now we have to find the area of each 5 scoring region. It means we have to find the area of the scoring region. Let's find the scoring area of the golden region, that is innermost. Area of the circle is what? Pi r square. Now pi r square is the area of the circle. Here is given the diameter of the golden score is 21 centimeter. That means the radius is here is of the gold score is 21 centimeter. It's a diameter. Now this radius is what? 21 by 2, that is 10.5 centimeter. Right? Now the area is of the golden region is pi r square, that is pi 10.5 square. Pi into 10.5 square, that means 22 by. Now pi into 10.5 square, it means 22 by 7 into 105 by 10 into 105 by 10. When you calculate this, let's calculate this with 7 1 is 7, 3 7 13, 15 7 is 35. Now this is 22 into 15 into 105 upon 100. When you calculate this, you get the figure as 1039.5. It means the area of the golden region is 1039.5 centimeter square. Right? Now this was about the golden region. Now when you come to this red region, you have to add this 10.5 centimeter the radius of the first. That means for this red region. Now let's come into the red region. Golden region has a diameter 21. That means radius is here is 10.5. Now next 10.5 is the radius of the red region. That means red region has the radius as 10.5 plus 10.5 the radius of golden region, then plus 10.5, that is wideness here is 10.5. Now the radius is 10.5 plus 10.5 is 21. Now when you calculate the area here is area of the using the radius 21, it will calculate the area of the red region as well as the golden region, right? When you calculate this area, right, when you calculate this whole area using 21 centimeter, you will be able to calculate the area of the golden region as well as the red region. Now area here is pi into 21 into 21. Pi is 22 by 7, and when you calculate it using 22 by 7 and 21 into 21, the area comes out to be 1386 centimeter square. Now it's not the area of the red region, it's the area of the red as well as the golden region. For the red region, you have to subtract the area of this total area minus golden region. Now we have calculated the area of the golden region was 1039.5, that is 1386 minus 1039.5 we have calculated earlier. Now when you subtract this, you get the area as 1386 minus golden region. 1386 minus golden region was 346.5. Now 346.5 minus 1386 gives the area as 1039.5. Now this is the area of the red region, this particular region. Now similarly, when you go for the blue region, when you go for this blue region, now here the radius is 10.5, that is golden, then red is white is 10.5, again plus 10.5. Now we'll get the radius of the up to blue region here. This is what, 31.5. Now when you calculate this area will be total from the golden, then red, then blue. The area is 31.5. The area is pi into 31.5 into 31.5, which is equal to 3118.5. Now area of the blue region is area of the total region minus red as well as golden. We have calculated the area of the golden as well as the red was 1386, right? So for the blue region we have 3118.5 minus the area of the combined area of the golden as well as red that we have calculated earlier, that was 1386, which is equal to now 1732.5. Now this is the area of the blue region, right? Similarly, you calculate the area of the black region as well as white region, right? This is for your homework. Now coming to the next problem. Next problem is the wheel of a car of a diameter 80 cm each. How many complete revolutions does each wheel make in 10 minutes when the car is traveling at the speed of 66 km per hour? Now the wheel of the car are of diameter 80 cm. Now we have to calculate the complete revolution does each vehicle make in 10 minutes. The car is traveling at the speed of 66 km per hour. Let's say this is the car wheel and this is the car wheel. This is the initial stage and this is the final stage. This is the initial stage and this will be the final stage. Now the car is running at the 66 km per hour, and in 10 minutes, let's say 66 into 10 minutes, that means 10 upon 60 hours. Let's calculate 11 km. That means in 10 minutes it traveled 11 km. Now it's traveled 11 km, right? And now let's calculate in one revolution it's complete how many kilometers or meters or centimeters. Now in one revolution, let's say this circle move, let's say this be the point. In one revolution, when let's just be a track here, when this point moves, right, this point moves like this and come here again, means again making a circle here, and this point moves like this in this fashion and come this to this point. This is called the one revolution. And it's one revolution, this point is shifted by 2 pi r because the circumference is 2 pi r, right? This bottommost point or each point is shifted by the 2 pi r. Now this point shifts here, the distance is 2 pi r. In one revolution is 2 pi r. Now this is 2 into pi into r is what? 40 centimeter, because diameter here is 80 and therefore the radius is 40. 80 by 12. Now when you calculate this pi into 80 centimeter is the distance covered in the one revolution, right? Pi into 80. Now I can say pi into 80, it's create the one revolution. 11 kilometer, or you can say 11,000 meter, or you can say put 2 more zeros, 11,000 then 100, that means 11 lakh centimeter requires x revolution. That means 1 upon pi into 80 into 3 zeros then 2 zeros. When we calculate this is approximately 4375 revolutions. Takes 4375 revolutions. Now last problem. Take the correct answer in the following and justify your choice. If perimeter and the area of circle numerically equal, then radius circle is. It says the perimeter. The perimeter here is 2 pi r is the perimeter, which is numerically, says the numerical word is very important here because you cannot equate the two different dimensions quantities. This is a centimeter or meter or something, that, and that's the area is meter square centimeter square. As a numerical equally, I can say this is pi r square, right? When I cancel this pi with the pi, 1 r with 1 r, I left with the r equal to 2. The answer is simple, r is 2 units. And this was the exercise 12.1. In next video I'll discuss exercise 12.2. Thank you for now. Have a nice day.